step with the reduction of order, since you have one of them, you say let y equals v e to the x, right? So v, the v prime e to the x, you agree? And then here, derivative of the first is v prime e to the x plus v e to the x. So far, so good. So you get v double prime e to the x plus 2v prime e to the x, because there's two of those, plus v e to the x. Plug them back into the original differential equation. So d squared y over dx squared is y double prime, no? So let's do the substitution. So we get v double prime e to the x plus 2v prime e to the x plus v e to the x minus 2 times y prime, which is this one here. So v prime e to the x plus v e to the x plus y, which is v e to the x, equals 0. So far, so good. Let's collect the like terms. So we have e to the x v double prime, and we have 2 from here, and we have minus 2 from here, so those two go away. And we have this, and these two go away. So technically, we just get this equals 0. Right? Well, e to the x cannot equal 0. So that means v double prime has to equal 0. And now that's easy to solve. Now you do the replacement. So you say let w equals dv over dx, or v prime. So this one becomes w prime equals 0. You agree? Implies that w equals, because w prime is just dw over dx equals 0. So that means dw equals 0 dx. And then you can integrate both sides. And as you know, dw is w, and 0 will just be some constant c. Yeah? Okay, fair enough. And so now we go back to w is just dv over dx. Let's call this c1. Is equal to c1, because that's what w is, dv over dx. Separate the variables again, you get dv equals c1 dx, right? Integrate both sides. So here now you get v is equal to c1x plus c2. And you know that y2 is equal to y e to the x from the very original substitution. So that means y will equal this times e to the x. So this, using reduction of order, we were able to figure out what the second one is, y2. Does this make sense?